cause dramatic sea level rise, which is absolutely contrary to the facts. There are weather stations at the South Pole and at Vostok, which is some distance away, but they're both on the Antarctic ice sheet, which is 10 to 15,000 feet thick in that area. And they all show that there has been no significant warming on the ice sheet since 1957. The record is complete from 1957 to the present, and if you draw a line through the changes, it's remarkably consistent with no appreciable change at all. The Antarctic ice sheet is not melting, and it's not surprising because the average annual temperature is about 58 degrees below zero Fahrenheit at the South Pole, and last year it reached in their winter temperatures of 106 below zero. Well, think about what it would take to melt an ice sheet that's 10 to 15,000 feet thick. You would have to raise the average annual temperature 58 degrees to get to zero, add 32 degrees to get to the melting point of ice, and then you need about another 10 degrees in order to get any appreciable melting. You don't get any appreciable melting at 32 degrees. So we're talking about you'd have to raise the temperature in Antarctica 100 degrees to get any appreciable melting at all. The only melting that's occurring right now is on the West Antarctic Peninsula, which is a little finger that comes off the main Antarctic continent to the northwest, and is surrounded by ocean water, which has warmed somewhat during the last warm period, which was 1978 to 1998, and has caused some melting there, but it has not affected the main Greenland ice sheet at all.
When you get into the details, it makes sense. It really makes sense.
The secret is in the data. The data speaks way louder than all the rhetoric that you hear from biased scientists and from the news media.
Some people may say that you're a biased geologist. How do you deal with that?
Well, the first thing I would ask is, what are my biases? I think there's a significant difference here between what the CO2 dogmatists are saying and what the geologists like me are saying and other people who deal with climate. And that is, the data speaks for itself way louder than all of the opinions that the scientists themselves may have. For example, you can paint an unsupported hypothesis of some kind. CO2 is causing it, for example, and without any data, that's just a scenario which may or may not be true. On the other hand, if you look at real data, which is what we're doing, the data speaks for itself, and you don't need my opinion for anything. So whether I'm biased or not has no effect whatsoever on the validity of the data that forms the basis for my opinions. My opinions aren't important, it's the data that's important.
Yeah, I get that. But the fact is now that this subject has gotten so politicized and there's big money at stake, there's a whole agenda at stake, wouldn't the weather stations also maybe be paid off or be influenced to play ball?
I don't know anything at all about that, and I think it would probably be impossible to assess. But what I do know is that Anthony Watts, who is a meteorologist, well-known meteorologist, has conducted a survey of virtually all of the weather stations in the U.S. This is not the world, this is the U.S. And what he found was absolutely amazing. He found temperature recording devices that were sitting next to exhaust vents on rooftops that were pumping hot air in the direction of the recorders. He found them at the end of runways where every jet that took off sent a blast of hot air, and all kinds of things. One of them was even over a barbecue. And what he found was 80% of the recording stations in the U.S. do not meet the standards for a surface recording station. And so then you ask the question, well, how good is the data then? And the answer is probably not very. And that's what both NASA and NOAA use as their starting point. And then from there, they further manipulate the data. So the validity of the data is the point in question. And so we have to look then at those data which give us an unbiased account of what actually happened. And probably the best record are the satellite records, because they are not human biased. These come from measuring instruments. They don't come from human-based kinds of recordings. So the big difficulty, of course, is that most of the claims that are made for global warming being caused by CO2 involve huge amounts of money, as you mentioned, and not insignificant trillions of dollars. And in addition, there is, unfortunately, a very strong bias in the funding agencies of the federal government. They spend, I think, something like $2.5 billion on climate-related research, all of which goes to the CO2 people, and none at all to objective-based, or very little, if any, to objective-based scientists who are looking at other possible causes of climate change other than CO2.
Right now, what you're stating in your declaration is that global warming is over. We are into the beginning of global cooling. Is that correct?
Yes.
Talk about why.
Well, again, we have to look at the past pattern and then project it into the future. And then we have to test and see if that kind of a prediction is, in fact, happening right now. So what I did in 1999, I looked at the past record of climate changes, warming and cooling, over the last 500 years, the last 1,000 years, the last 10,000 years, and so on. And I saw a distinctive repeating pattern with an oscillation of about 25 to 30 years. And then I looked at Pacific ocean surface temperature data. This is called the Pacific Decadal Oscillation, and it shows that the Pacific has two modes of temperature. One is a warm mode, one is a cool mode, and it flips back and forth like an on-off switch. It's not gradual. It will suddenly flip from one mode into the other mode. And so what I discovered was that in 1999, the Pacific switched from what had been a warm mode for about 22 years into its cool mode, and we have 4 of these changes that have occurred in the past century, and each time there has been a change in the mode of Pacific ocean water temperatures, we've had a global climate change. And part of that is that the same thing happens in the Atlantic Ocean. It's a little bit different, but the same general thing takes place. And so I put this all together, and I came up with a pattern that says, okay, each time in the past century that the Pacific has changed from its warm mode to its cool mode, we've had a period of global cooling. Each time it switched the other way around, we've had a period of global warming. It so happened that 1998 at that point was the second warmest year in the century, and I predicted that if the same pattern held as had happened all during the last century and for the past 500 years, that we would be entering a period of global cooling beginning sometime after the year 2000. And people thought I was crazy because we just had one of the warmest years, second warmest year of the century. And it was based entirely on the geologic data, not on what was happening that particular year. Well, it turns out that we have not, despite predictions of a 1 degree increase in temperature every decade by the IPCC and by the CO2 dogmatists, we have not exceeded the 1998 temperature in the past, and now 13 years. And the overall trend is slightly downward. It's not strongly downward yet. And so my prediction, let's just take the year 2000, over that 12-year period, was that we should not experience more warming beyond where we were in 1998, but we should have some cooling, and it's happening. So the proof of the pudding is in the eating. What I predicted is indeed happening right now. If we ask the question, why is it happening? The sun is behaving very peculiarly. It hasn't behaved the way it's behaving right now since the last really cool period, known as a Dalton minimum, about 1800, about 200 years ago. So we're experiencing right now, we're in a solar mode that reoccurs about every 200 years. And we have entered that mode, which tells us then that maybe what we're seeing is the cooling effect of what's going on with the sun, especially with the sun's magnetic field, not just with the solar output, but with the magnetic field. And that gets into some technical things.
Would you explain a little bit about the magnetic field?
Sure. The sun has a very strong magnetic field, and what it does is it acts as a shield for incoming radiation from space. And we know that when there is radiation going through the atmosphere that it ionizes